Hello, where am I talking from today? I am talking from Orkney, up in the islands. There is a Heriot-Watt University campus in Stromness, Orkney, and I am setting up the Island Center for Net Zero, which is a action research program working with the people, the companies, and the councils of the islands to achieve this energy transition that we're talking about. So if all systems are go, I'm going to launch into my discussion of what I think that energy transition research is. I'm going to say it's science-based, and I'm going to try to convince you to change your perspective. So the first question here is the energy transition. You should recognize these pathways, these representative pathways of emissions from the IPCC. And the international agreement is to follow the pathway that is safe for the climate, and that requires dialing down fossil fuel by 80%. All right. Is that what energy transition means? Because when I Google energy transition, the top hits, I've pasted them here for you. They're all from reputable organizations. And the thing that we see that all of them have in common when we're thinking about energy transition is apparently wind turbines. Okay. What does the research funding landscape look like, right? That's our guidance for what we should be working on to achieve the targets of the country. So let's look at the energy transition research funding landscape. Definitely, we've got some economic research, behavior, economic efficiency, productivity, green growth, this sort of thing. Definitely, we've got things like carbon price, incentives, offsetting, emission trading. For sure, we've got alternative energy, smart grid storage, and this has been going on since the 70s that we've been looking at those alternative energy sources and approaches, and that's really what got me into engineering. Oh God, a long time ago, 40 years ago or something. And then of course we've got really fun things. And also for about the last 30 years, we've been working on these sort of hopeful things. And we've got electric cars, yeah, and roads, and innovation. Man, if we could just innovate, if we could just do new things, kind of what we've been doing. But what I'm thinking is that there's a giant elephant in the room here, and it is directly addressing the fact that we use too much fossil fuel to avoid dangerous climate change. Okay, so yes, all those things, the wind turbines, the green economy, circularity, everything, please, it all matters. But what really matters is dialing down fossil fuels by 80%. So this is what the UK government funding is onto right now, right? Okay, let's go back to the science for a minute. We know that concept of safety limits and failure limits, don't we, everybody? It's engineers are pretty comfortable with it. You do the calculations from physics of what you're pretty sure would, according to the models, break the thing. So collapse the column, for example, collapse the bridge. And then you say, okay, that's the load to failure. And so the failure limit is about 50% of that. So I'm going to double, I'm going to have a factor 2 on my safety. And what that is it gives you enough probability that if you stay below that failure limit, it won't actually fail, right? We don't actually want things to fail. So when I apply that thinking to the IPCC's modeling, what I see is that this 2 degrees C is a massive fail. There's no way that's the collapse of the column. That is the crash of the airplane. That is not what we're going to do. And it's figured out the same way as regular failure limits. So in other words, we cannot load to failure. Do not go there. And so the only way, this is the Mauna Loa CO2 atmospheric data. We know that the safety limit is back here in the 1990s. The Kyoto Protocol was that we were going to not load to the safety limit. Well, we didn't do that, continued to grow. And so now this sort of not loading to failure means that the amount of CO2 in the atmosphere stops stops doing what it's been doing. It stops growing at 2 to 3% per year. And so what are the research questions then? What are the research questions, given that that is the answer? Okay, how do we, this is a graph of the world consumption of energy, a pretty simple graph, and you can see oil, gas, nuclear, hydro, and coal, the big ones. You can also see that little orange slice there. That little orange slice has been growing, and that is all of our wind, solar, biofuel, and geothermal combined. All right, so that's been growing. So how do we achieve that stopping of CO2 emission accumulation? Can it possibly be more wind, solar, biofuel, geothermal? Can it be? Can it be taking some of that little slice and making hydrogen out of it? Would that do it? Could it be sucking CO2 out of the atmosphere? I love that one. I can hear the sucking sound. Or is it, how do we dial down fossil fuel production and adapt to that? I will tell you that is the answer. Correct. Ding, ding, ding. Prize for you. All right. How do we do what the kids want? You've seen these climate strikes by kids. Yes. What do they want? They want apparently action, net zero. They want not climate change, right? So they want action. They want to leave some of that fossil fuel budget, that, you know, not loading to failure, leave a little bit of that for them. Problem. What is the problem with that? Why don't all of us work line of sight directly on what the kids want? There is a slight problem. Those kids don't fund research. And we have to have funding for research. So what are we going to work on? How do we offset our fossil carbon emissions? That's a popular theme. Well, I've put here the average lifestyle footprint of emissions for your average developed country person and for an average trade. And I hope what you can see is that there's a little bit of an imbalance. What you would have to do is spend about 100 days planting trees, 2,000 and some trees, where there weren't trees before, because remember, where trees have already been cut down, where there was forest, planting that back doesn't offset fossil carbon. It's just sort of putting back carbon into the biosphere that was there before. So finding a place where there haven't been trees, humans didn't cut them down, and put more trees there. Yeah, spend 100 days every 28 years, and maybe, I don't know. That's maybe, probably not. So what are we going to do? How do we dial down fossil fuel production? I've now taken that cumulative carbon pathway that we were there. There's the accumulation of carbon dioxide in the atmosphere. And that's just carbon dioxide. We do have other greenhouse gases that have to do the same thing. And that accumulation is going to stop and leave us a little bit of wiggle room on the failure limit. Here's the historical oil production. And in order to get that curve to stop growing, you have to do that with how fast you're growing it. Yes. This is just really simple math. It's a spreadsheet you can make, and it's something you sort of have to understand, that this is our research question. How do we dial down by at least 10% a year now, not by 2045, but now, because that much carbon that we're putting into the air every year is simply too much. All right, energy transition means dialing down fossil fuel. So what is the energy transition engineering research? What sort of things would you work on? I'm thinking that not what you would Google. Let's think of something else. In engineering, you only have a chance of figuring out what to do if you have the problem definition right. All right. So how are we going to define the problems? How are we going to define the research questions? I'm going to give you this monkey trap tool to help you think through how to define the problems. Mostly, we're going to understand that there's no solution when you're in a monkey trap problem. All right. So the monkey has a problem of needing something. That's what got them into this in the first place. So we tell ourselves, our story is that we need fossil fuel. We need growth. We need development. We need to cut down those forests. We need to fish those fish stocks. We need to do these things. Yeah. And that's why we can't get out of this mess. Now, things might not be the way we want them to be. We wish that the jar opening was bigger, then we could get what we need. But that isn't the way it is. And that's just a thing. It's just the way it is, all right? We wish that we had an out. We wish we had a way to get away from this, to move to a safer place so we could then develop new technologies that would maybe we could cut ropes, maybe we could break jars, these offsets, maybe we could do something. We really kind of wish that the hunter wasn't coming, but we know that he is. So climate change is here, it is coming, it is getting worse. And as the hunter approaches the monkey gets more and more upset and more afraid and more agitated. And the ability to rationally think and problem solve gets worse. So on top of all of that, it's a big setup from the start. Monkey soup has been cheap and tasty for as long as anyone can remember. We don't know anything else, all right? It looks like we're a bit stuck, and the truth is we are, because any time that you're going to turn around and you're going to look at the problem in the face, which is fossil fuel, nitrogen oxides, refrigerants, all of these man-made effects must decline very quickly right now, you're going to hit wicked problems. Wicked problems are where the thing that you know must happen, you also know can't happen. It's really painful on the brain. Now, I think once you understand what wicked problems are, you can start to get them into a box where you can start to manage them. All right, a wicked problem presents like this. Okay, we know we're using 100 million barrels per day of oil in the world. It's handy, it works great, we like it. All right, but what we also know is that it's not sustainable. We also know that we're using it because it works, it meets our needs. And so if the oil supply stopped flowing tomorrow, then the world would crash. Everything would fail. It would be zombie apocalypse. There would be no hope. But if the oil supply doesn't start declining by at least 10% a year now, then the climate system will fail. And that isn't much better than zombie apocalypse. So we are in what's called a wicked problem, where what we are doing works great. It was well engineered. It was not engineered by you. And so how could you possibly change it? We're talking about big, complex systems with long supply chains, lots of inherent and incumbent technology and economics involved, and yet it's not sustainable. We don't know how else we would meet our needs if it wasn't that way. We're already doing it, but it causes so much harm. There's accidents, there's pollution, there's globalization and the effects it has on other people's lives and the environment. So, we have to change this. We get that. We get it. We have to change it. But you know what? Today, I don't know how I would change it, right? How do we come out better from this dial down for the end users, vehicle makers, travel industry, oil industry, everybody? That is the only way to figure out the answer to this wicked problem, is to find out how we come out better. All right, to do that, we have to perturb ourselves into a problem-solving space. The way to perturb yourself into a problem-solving space is to give yourself the problem. Make sure you've got the problem definition correct. We are going to not overload the system and fail it. Therefore, 10% dial down of fossil fuel occurs in 2022. Imagine that happened. Imagine the solution is found. Now, what do you do? What needs doing? Now, it doesn't stop there. There's now 20% less in 2 years. And you know what? There's 80% less overall. And if you've got some sort of an inherent system that uses fossil fuel, probably if you're going to do a project of change, just getting to the 80% reduction right now would be the obvious way to manage those risks. Is it possible to design something, whatever it is that you know that you're working on, that's 80% less fossil fuel required and is better. All I can tell you is that all of the transition engineering projects I've ever worked on, the answer is absolutely yes. That's nice. That's what we could do. Slight problem. How in the world would you get the oil companies to dial down oil production, the coal companies to dial back coal production, the gas companies to wind up gas production, to leave some for later? We need some new research, and we need it now, on new business models, new policies, new regulations, asset management, petroleum engineering. Do petroleum engineers know how to back down production on an oil field so that it can be used for much longer at a lower rate? Do they know that? Is that in the textbook? How about refinery management when the throughput is changing, going down? How about retail management and interaction with customers and post-oil ventures? How in the world would any of this even begin to happen? And the answer is, how do oil companies make more money dialing down production than pursuing more growth? If you could answer that question, then all of, that would be like the first domino to fall. That would be it. That would be the one, because these companies exist only to profit, only to return profit to shareholders. If they make more money, if their profitability is better, not pursuing drilling in the Arctic, not pursuing 5-mile deep oil off Guyana, then they will do it. Okay. What does the rest of the world think about that? How in the world, how do we manage the oil dial down? What does that look like? Well, what we know is that the OECD and the IEA, these international organizations that are meant to keep everything the way it is, they've actually said we will need to reduce oil production by a lot. All right. So the research is, how do we actually do it? International energy negotiations for dial down, international economics, international energy transition. These are the research areas of today. How do we do that? How do we research these things? How do we forward plan and manage this dial down? How do we set up international price control? Because there has to be a new model for how this works, because the price has to go up as the production goes down. That's how we get the profitability to return for the oil sector. How do we adapt personal freight and transport? It uses too much oil now. It's going to use less. How do we adapt economies from consumptive to regenerative? How do we redesign packaging, retail? This list could go on. There is no shortage of energy transition research. How do we? You do it. You get onto it and you do it. There is a methodology that starts with that definition of the wicked problem that I just gave you, learning how to manage wicked problems, learning how to manage your perspective so that you can look direct line of sight at what exactly needs to be done right now. And that unlocks your problem-solving ability to address that. And that methodology is called transition engineering. It is available for training now for engineers and for managers and non-engineers. There's transition engineering consultancies and programs. There's also a book that you can get and read for yourself. It is a very accessible book that explains this methodology. And there's a global association, a professional peer associate and engineering association that you can join to work with others and find out what this looks like when we ask, how do we do what absolutely needs to be done? So thank you for your attention, and I hope that there will be lots of questions.